Hello everyone, welcome back to my YouTube channel. So today I'm gonna talk about one of the very important question asked in GATE 2022, and that again this concept is not covered anywhere in India, right? So this concept is one of the very important concept which is used everywhere nowadays. Okay, in fact way back also. So if you don't know the properties of Markov chain, so you will not be able to solve this question, right? Because we study in digital circuits regarding state transition is okay. Okay, we talk about state diagrams over there, right? But this is the state transition diagram, okay, which comes from the concept called Markov chain, right? If you want to represent Markov chain, so you need to understand the state transition diagram, okay? So if you don't know the property of this, you cannot solve this question, right? So this question was asked in GATE 2022 in electronics and communication paper. So first of all, we will understand what are the properties of Markov chain, and this concept is from random process, okay? Because you will find in the discussion that this is completely a random process where the probability will be involved, right? And if you're going from one state to another state, right, so there will be some probability associated with that, right? Okay, so this is the question which we will see, we will solve here, this question, right? This question was asked in GATE 2022 in ECE paper, okay, for 2 marks. So you can see a state transition diagram is given, okay? So before that, before solving the question, we must understand the Markov chain process, okay? So just I have taken one example. Whenever I try to explain any question, I just take one example so that this concept could be cemented in your mind, right? Okay, so this is a concept. Just I'm taking one example here. We are in a restaurant, right? So if we are going to the restaurant, so suppose any restaurant is there and they are selling today hamburger, and tomorrow they are supposed to share, they are supposed to serve what the pizza, right? So this is going to be hamburger here, okay, and this is pizza, your favorite, okay, and this is going to be hot dog. So suppose today they are serving what, hamburger, right? And tomorrow they are going to serve pizza, right? So what is the probability that whether are you able to predict whether they are supposed to serve pizza tomorrow, or okay, what is the probability, right? So suppose from the past, if you are able to predict future, okay, this is a concept of Markov chain, okay? So you can see here today they are serving pizza, they are serving hamburger, okay, and what is the probability that to get served hamburger, that is 0.2, okay. You can see here these arrows are associated with these transitions, right, and they are weighted here with some probability 0.2 or 2 by 10, you can say. And this I'm considering that today they are serving hamburger, and I'm predicting that they are supposed to serve pizza tomorrow, okay. So what is the probability there? That is 0.2. Or we can say that tomorrow again they are supposed to serve hamburger. So what is the probability that that is 0.2, right? So if you are able to predict future based on the past, okay, depending upon the current state, right? So that is what the Markov chain is, okay, remember. So so what are the properties of Markov chain? See, Markov chain is used everywhere, right? In statistics, right? In biology, in fact, in various processes, okay, in physics as well, in economics, okay. So you can see here in the business, in fact, okay, nowadays you might have heard the word machine learning, data science, okay. There are various terms, right, which is used to predict, okay. So whatever is being served today, what is the chance that tomorrow that product will be served, right? So here you can see, suppose today pizza is being served, what is the probability that tomorrow, the pizza will be served? So there is no transition. Okay. And what is the probability that tomorrow they are supposed to serve hot dog? So I hope you can understand this. And these are the weight which are associated with transition diagram. Okay. So transition, between two states. Okay. So the very first property, okay, we need to understand the properties of Markov chain. Right? Properties of Markov chain. We will understand the properties of Markov chain, then you can solve this question. Okay, we will solve that question within 10 seconds. I can guarantee you, right? So the very first property which the property which is associated with Markov chain is what? The future state depends only on the current state. Okay, future state depends only on the current state. Okay, only on the current state, not the steps before, in fact. Okay, not the steps before. Okay, what is the meaning of that? Right, we will see with one example again, right? Okay, so a future state depends only on the current state, not on the steps before. Or in terms of probability, you can say that the probability xn plus 1 will be equal to x. Okay, given that xn, okay, equal to xn, right? This is the very first property which you must understand. Okay, you must keep in mind for the Markov chain. And the very important second property is there, right? Second property I'm writing here, right? The second property says that the sum of weight, okay, sum of the weight, let me erase this, sum of the weight okay of the outgoing arrow, okay, of the outgoing arrow, okay, from any state, okay, from any state is equal to 1. Okay, why it is happening? So because weight meaning here is the probability, right? And to make the sense, to make sense for the probability, we need to add all the probabilities, and that should sum to 1 always. That is what the case is. Okay, so I hope you understand that. Okay, so this is going to be second property, right? So with the help of these two properties, we can answer that question which was asked in gate 2022 in electronics and communication paper, right? Okay, so uh, let's use the first property first and solve this question. Suppose the day 1, right? Day 1, they are selling this pizza, right? This is pizza here. Okay, and second day, or you can say tomorrow, or second day, you can say, right? They are selling what? The hamburger. Okay, hamburger they are selling, right? And third day, okay, third day they are selling again pizza. Okay, so what is the probability that they will serve, what is the probability that they will serve hot dog in fourth day? Okay, hot dog, right? They will serve hot dog. Yeah, so can you tell what is the probability that? So from the first property, as I said, that the future state depends only on the current state, not the step before. So you can see here, if they are selling what, they are serving pizza, right, on the third day, so they will be sharing serving, okay, the hot dog with the probability 0.7. Okay, because this is the current state for okay, I hope you understand, right? So you can see that the fourth, the probability will be 0.7. Okay, So that is what the very important concept. And some of the weight of the outgoing arrow from any state should be equal to 1. So you can see from the Markov chain, okay, this is the Markov chain I have considered, right? With an example of any restaurant, the item they are serving, you can take the example of McDonald's, right? So you can see here outgoing, just you have to focus on outgoing branches, okay, outgoing transitions. So this is outgoing, right? So 0.2 is here, and this is 0.6, and this is 0.2, right? So 0.6 plus 0.2 plus 0.2, that is coming to 1, okay? So my second property is also justified and proved, right? Okay, so with this concept, let's solve the gate 20222 question, right, which was asked in gate examination, okay, in 20. So you can see here, yeah, so having transition probability, P1, P2, P7 is shown in the figure, okay. Example, P1 denotes the probability of transition from state A to state B, right? For this state diagram, okay, we have to select which is universally true, okay. So you have, this is the concept called Morkov chain. This question was asked from Morkov chain only, so you have to use second property here, right? So you have to see what sum of all the weight, okay, sum of the weight of the outgoing arrow, sum of the weight of outgoing arrow, let me take again different color here. So yes, so you can see here, if you are in state A, or you can say we are in hamburger day, okay. So outgoing branch is this, that is P7 here, right? You can say P1 plus P7, right? P1 plus P7, this is P1, okay, P7 and P4, you can say, right? If you are in state A, so P7 is outgoing here, and P1 is outgoing, and P4 is outgoing from state, right? So this should be equal to 1 for the state A. Now state B, come to state B, outgoing, okay, so P2 plus P3, okay, only two transitions are there, they are so P2 plus P3 must be equal to 1, right? Okay, and when you are in state C, okay, I mean when you are in you can say hot dog day, okay, you are being served, so you might be excited as well, right? Okay, but people are excited usually for pizza, yes. So in fact, I equally excited for pizza in older days. I mean, in my childhood I was not liking, but now yes. Okay, so when you are at state C, so you can see there are couple of okay, yeah, again P5 plus P6 equal to 1. There are a couple of branches, going out, okay. I hope this is clear. So you can see from these state B and state, so you can equate them. So from here you can conclude that the P2 plus P3 should be equal to P5 plus P6, okay. And this question was MSQ type, okay, MSQ, multiple select question. So from first, P1 plus P4 plus P7 means your option C is going to be correct, okay, right? P1 plus P4 plus P7, and P2 plus P3 plus P equal to P5 plus P6, right? So P1 plus P3, yes, P2 plus P3, yes, this. So option A and option C is going to be correct here, right? These two options will not be correct. Right? So if you know the concept, if you know the properties, you can solve any question, okay, within 10 second to 20 second. I hope this is clear for everyone, right? I will be bringing more new concept, okay. I will be opening your eyes from where questions are being asked, right? So you have to cover all the topics such as in the random process, okay, not only regarding the autocorrelation and all those concepts, right? You have to cover everything. So you need to follow some of the very good book for random processes like Papoli's, okay. You can follow Papoli's, and there are various book for statistics, right? And nowadays why they are bringing these kind of a question, because you can see people are going from one domain to another domain, like data science, nowadays data scientists are in much more demand, okay, in any industry you go for, right? In fact, electronic guy also going for artificial intelligence or machine learning, right? So I hope this is clear for everyone. And this question is not from the digital circuit, remember, right? People, most of the people will consider that this question is from digital circuits. Yeah, we study over there the state diagrams, they are definitely, but okay, because in digital circuits I did not find, like, along with the state diagram, one discuss about the probability as well, right? But here you are trying to predict future, right, based on the current state. So Markov chain plays an important role over there. I hope application you understand from past to future. Okay, if you want to predict, yes, I hope this is clear for everyone, and we will meet again with the new session. So I hope if you have liked this session, hit the subscribe button and share among everyone. Thank you so much. Okay, enjoy the solution. Okay, real solution. Thank you.